So as noted before, the value of a trig function is more about referencing a particular value than performing any kind of operation. There's a set value for sine of a particular angle, a set value for cosine, put them over each other, we get tangent, and so on. Given that these are predetermined values, it should be simple to go in reverse and, for example, find the angle that gives us a particular sine value, right? Generally, yes, absolutely. If we can construct a relationship between sides and an angle, such as setting up a hypotenuse of a right triangle as the terminating side on the unit circle, we are completely able to use the sine or cosine values to find the measure of the angle, just as we're able to use the angle to find the measures of the sides of the implied right triangle. We just have to keep one technicality in mind. As noted, trig functions are cyclical as all get out. Each point in the range recurs an infinite number of times as the domain goes on. Even within our standard 2 pi unit circle frame of reference, each y value is hit twice over the course of a cycle of each trig function. So these repeated values are problematic if we're setting up an inverse. However, those repeated values are also absolutely predictable. We know when they're going to repeat, and because of this, we know how to make sure they're not going to repeat. The key to setting up inverses of trig functions is to restrict the domain of the inverse so that the range contains all possible values without repeating. We're basically going to take 1/2 of a trip around the unit circle for each of the functions, but even that half cycle is enough to get the inverse to work correctly and relate an angle with each value for sine, cosine, and the rest. So the domain for the inverse of sine, or arcsine for short, and also because it kind of sounds cool, is from -1 to 1, which gives us a range of -π/2 to π/2, or -90 degrees through 0 to 90 degrees, just as a sine function from -π/2 to π/2 goes from -1 to 1. Domain for arc cosine is also -1 to 1, and the range is 0 to π. The domain for both arctangent and arccotangent is all real numbers, which actually makes sense when we relate it back to the asymptotic behavior of regular tangent and cotangent functions. The range for arctangent is -π/2 to π/2, and for arccotangents it's 0 to π. The inverses for secant and cosecant follow the same rules, but the need to have only one cycle without repeats means that they're split, which is one of those things that looks weirder than it actually is in practice. But in general, using the inverses of trig functions is just as easy and straightforward as using the regular functions. So, let's answer one of those perennial background questions in math. What are the angles of a 3, 4, 5 right triangle anyway? We draw the triangle and label the sides. At this point, it's easiest to stay within the framework of the unit circle, so we have to get the triangle to fit the unit circle. That means a hypotenuse of 1, which means we divide all 3 sides by 5. One leg is 3/5, one is 4/5, and the hypotenuse is 1. The sine of the angle at the left is 3/5. If the bottom of the triangle is the initial side and the hypotenuse is the terminating side, our sine reading would be 3/5 or 0.6. From here, finding the inverse is a pure calculator operation. 0.6 second inverse sine, and our angle is just about 36.87 degrees. The other angle is 90 minus 36.87, or 53.13 degrees. Right triangles are the fundamental structure for trigonometry, which we will consider much more thoroughly in the next section.